Okay, next problem is of find the DTFT of the signal, that is x of n is equals to a power mod of n, where mod of a is less than 1. Solution is going to be, first we have to write the equation, that is x of e raised to j omega is equal to summation n varying from minus infinity to plus infinity x of n e power minus j omega n. Then what is the given signal, that is x of n given as a power mod of n, that you have to write, and remaining is as it is. Then what is the mod n is consisting of, it is consisting of both the negative values and also of the positive values. For that reason, first we will consider for the negative values, where the summation is going to vary from n minus infinity to minus 1, and then a power minus n for negative values. For that reason, minus n e power minus j omega n plus summation n varying from 0 to infinity a power n e raised to minus j omega n. Then now when I change the limit, observe here, from minus infinity to minus 1, I am going to change as n is varying from 1 to infinity. Negative sign it's going to be changing, and the limit is also going to change. When it is going to be changing, our power, what is the power is going to be, it is minus n. The whole is going to be changing with the power minus 1, means for the whole we have to multiply with the power as minus 1. Okay, changing the inverse operation is going to be, that's what you have to remember. Okay, so inverse means a raised to minus n is going to be taken as a raised to e raised to minus j omega n is going to be e raised to plus j omega n. That's for, based on that I can write as a is here, the power is taken fully, okay, in the power factor, a e raised to j omega power n commonly taken. Then here also it is written as in terms of a into e raised to j omega n in terms of power, whole power. Okay, then we know the equation, that is summation varying from 0 to n. If it is of alpha means 1 divided by 1 minus alpha, right? The same thing here, if when it is varying from 1 to infinity means alpha divided by 1 minus alpha. Alpha is nothing but this, whatever may be the parameters you will be getting in this section. Okay, therefore I can write as a e raised to j omega divided by 1 minus a into e raised to j omega plus 1 divided by 1 minus a into e raised to j omega. Take the LCM here, then do the simplification. You will be getting as x of e raised to j omega is equals to 1 minus a square divided by 1 minus, write e power j omega in terms of cost parameter. Okay, multiply and simplify. After simplification you will be getting this result. Okay, I hope you can do of that. It's a simple calculation way, you can do that. 1 minus 2a cos omega plus a square you will be getting off. Then next problem is of evaluate the DTFT of the signal x of n is equals to delta of 6 minus 3n. Sketch its magnitude and phase spectra. The solution is going to be, first you write the equation for DTFT, then substitute for x of n as delta of 6 minus 3n into e raised to minus j omega n. Then impulse function occurrence is going to be obtained as when it is going to be, a delta function is going to exist at 0th value only. When you will get 0 value, when 6 minus 3n is equals to 0 means at n is equals to 0 will be, the whole function is going to be 0, means delta of 0 you will get, delta of 0 you will be getting a signal as delta of signal. That's what the meaning. Then x of e raised to j omega is going to be equals to delta of 2, means the n value should be 2. Therefore then e raised to my n value is of 2 minus 2 j omega. Delta of 2 is nothing but 1, so therefore we will be getting as e raised to minus j 2 omega. What is the magnitude of this? Magnitude is going to be 1, and the phase is going to be based on this parameter, that is of minus 2 omega. Here the magnitude it's almost similar to the what we already gone through with the Fourier transform. From 0 to minus pi to plus pi it will be 1 only. That is about the magnitude. The phase is going to vary from at minus pi, it will be getting as 2 pi. At pi, it will be getting as minus 2 pi. Okay. Next is of compute the DTFT of the signal. X of n is equal to 1 by 2 power n into u of n plus 3 minus u of n minus 2. Here, substitute for x of n. First, you have to write the DTFT equation. Then, substitute for what is x of n given, that is 1 by 2 power n e power minus j omega n. From this, we have to find out the limit. What is the limit is going to be? U of n plus 3 means the signal is going to be shifted towards 3 positions towards left side, and it is going to be existing. This is about your minus 3. Then what is u of n minus 2? The signal is going to be shifted by 2 position towards right, and it is going to be existing. Then these are going to be subtracted, right? From this part, from 2 the whole signal is going to be 0, means where the signal is going to be existing now when I do the operation here, means from minus 3 to, if I take the limit here, from minus 3 to 2, you will be getting the signal minus 3 to R1. Once you check with this, from at 2 it will be 0, but here it is going to be right, it will be at 1, it will be getting the signal. Therefore, minus 3 to 1. I hope you will be doing of this. One more time, you just cross verify this. Summation n is varying from minus 3 to 1, then 1 by 2 power n e raised to minus j omega n. Then that is equals to summation n is varying from minus 3 to 1. Here 1 by 2 e raised to minus j omega. The power is taken as n. Then put L is equals to n plus 3. When I substitute L is equals to n for 3, then I can write as x of e raised to j omega is equals to summation L varying from 0 to 4. Then 1 by 2 e raised to minus j omega power, the n value is going to be changing as L minus 3. Okay. Therefore, what I can write now, that is going to be 1 by 2 e raised to minus j omega power minus 3 is a constant that I taken outside. What is the remaining part where it is varying from summation L varying from 0 to 4, 1 by 2 e raised to minus j omega power L. Just you solve for this and you will be getting as x of e raised to j omega is equal to 8. This based on this, right? Minus 3 is there. 8 e raised to j 3 omega. This operation you have to do. That's it. Multiplying there. This minus 3, 1 by 2 power minus 3 means 1 by 2 power, again 1 by 1 divided by 1 by 2. Inverse raised there, right? You will be getting as 8. Then the equation of this is going to be 1 minus 1 by 2 e raised to minus j omega power 5. Or else, if I before that, I will be as 1 by 2 power 5 e raised to minus j 5 omega divided by 1 minus 1 by 2 e power minus j omega. You will be getting off. Then find the DTFT of the signal. X of n is equals to n into 1 by 2 n power mod of n. When you get n means some differentiation operation we have to perform that. You should keep in mind that when you have any of the signal, if it is multiplied by n, means we have to use the property. What is the property we are going to use? We know that in the previously we gone through that a power mod n DTFT is going to be 1 minus a square divided by 1 minus 2a cos omega plus a square. Therefore, mod of a is less than 1. What you have to do? Instead of a, here it is given as 1 by 2. That you have to replace. 1 by 2 power mod n DTFT is going to be, substitute wherever a is there as 1 by 2. And then solve, you will be getting as 1 minus 1 by 4, 1 minus 2 into 1 by 2 cos omega plus 1 by 4. Solve for this, you will be getting as 3 by 4 divided by 5 by 4 minus cos omega. Then using frequency differentiation, what you have to do? Differentiate the whole signal. Therefore, n into 1 divided by 1 by 2 power mod n DTFT is going to be j d by d omega of 3 by 4 divided by 5 by 4 minus cos omega. To the differentiation, then you will be getting as minus j 3 by 4 sin omega divided by 5 by 4 minus cos omega square. Okay, differentiation of the numerator denominator, you can go do that. After doing, you will be getting this result. Then about the next problem is of using the appropriate properties, find the DTFT of the following signal. From the question, what is x of n is going to be 1 by 2 power n u of n minus 2. From n minus 2 means it is of a shift operation, right? Now, what is the shift? How much the shift is occurred? First, you have to check that and then modify the equation of 1 by 2 power n. What I can modify? Observe here, what I wrote 1 by 2 power 2 into 1 by 2 power n minus 2. This should be equal. Whatever the problem it is given, the power of half part should be equals to the u of whatever the function. If it is given n minus 3 means you have to take 1 by 2 power 3, 1 by 2 power n minus 3. Okay, if I add of this in power, in terms of power, I will be getting the same. So yes, of course I will be getting the same. So I can write out like this. Whichever the problem it is given, we have to do this one. Okay, then we know that 1 by 2 power n u of n, the DTFT is going to be 1 divided by 1 minus 1 by 2 e power minus j omega. This we already done. Then using of the time shift property, I can write as 1 divided by 2 power n minus 2 u of n minus 2 DTFT is going to be, what is the shift is done? E power minus j, how much shift? That is of 2. For then 2 omega. Instead of n, it is going to be 2 omega into 1 divided by this as it is. 1 divided by 1 minus 1 by 2 e raised to minus j omega. After this, we come across of only of this part. Now we have to multiply with this function, that is 1 by 2 power square. That is, what is the property? Linearity property, a into x of n, right? The same thing I can write here. In the both the parameters, I can write as 1 by 2 power square, 1 by 2 power n minus 2 u of n minus 2 DTFT is going to be, here also we have to multiply the constant value. Which constant value? This one. Okay. Therefore 1 by 2 power 2 e raised to minus j 2 omega 1 divided by 1 minus 1 by 2 e raised to minus j omega. Then this value is going to be 1 by 4 e raised to minus j 2 omega divided by 1 minus 1 by 2 e raised to j omega. Therefore, the DTFT equation is going to be x of e raised to j omega is of the whole function. After multiplication, you have to write. This is important, like this problem it is asked. Okay. Then the next problem is of using the appropriate property, find the DTFT of the following signal. Sin x of n is given as sin pi by 4 n into 1 by 4 power n u of n minus 1. Observe here, one is shift operation and again we have to change the power. Then here the function is given in terms of sine. Whenever the function or any input signal it is given in terms of sine or cos, we have to write in terms of e power, in terms of exponential. So we will go with the 1 by 1. X of n is going to be, first I write the sine function in terms of a exponential parameter, that is e raised to j pi by 4. What is there in that? That into n minus e raised to minus j pi by 4 n divided by 2j. Then Observe here, already we done in the previous. What we can do, how much the shift is going to be? N minus 1. 1 by 4 power n minus 1. Then 1 time, right? For that reason 1 by 4 power 1. I can write or else I can leave off. It will be indicating that this power is 1. Then u of n minus 1. Then multiply each of the parameter with the exponential. When I do that, I will be getting as 1 by 4 into 2j, that is you will be getting as 1 by 8j e raised to j pi by 4 into n, 1 by 4 power n minus 1 u of n minus 1 minus e raised to minus j pi by 4 n 1 by 4 power n minus 1 u of n minus 1 will be just multiplication done. Then that is 1 by 4 power n u of n DTFT is going to be what? 1 by 1 minus alpha. This you just keep in mind that alpha raised to n u of n DTFT is going to be, it's like a general formula, that is 1 divided by 1 minus alpha into e power minus j omega. You will be getting, here it is of 1 by 2 means it will be changing 1 by 2. If here it is of 1 by 4, 1 by 4. It is of 3 means again here it will be getting as 3 only. Okay, you will be getting, then using of the time shift property, that is of 1 by 4 power n minus 1 u of n minus 1, I can write as DTFT is going to be e raised to minus j omega, and the DTFT equation of 1 divided by 1 minus 1 by 4 e raised to minus j omega. If I simplify this, I will be getting as 1 divided by e raised to j omega minus 1 by 4. Then using frequency shift property, frequency shifting property, what I can write here, e raised to j pi by 4 n 1 by 4 n minus 1 u of n minus 1 is the DTFT is going to be, how much the, how we are why we have to choose frequency shift? Observe here, e raised to j pi by n is pi by 4 into n is there. For that reason frequency shift. J, what is the beta value here? Pi by 4. For that reason e raised to j omega minus beta, that is pi by 4 minus 1 by 4. Then using of a linearity property, why we go with this? Here the constant value is there. For that reason, that I can write as 1 divided by 8j e raised to j pi by 4 n, 1 divided by 4 power n minus 1 u of n minus 1 DTFT is going to be 1 divided by 8j 1 divided by e power j omega minus pi by 4 minus 1 by 4 you will be getting. In the same way, this is for the first case, for only for this we done. Next for this value, only change is of, instead of plus j, here it is of minus j, that's it. So what I can write, similarly I can write as, instead of plus j, here the minus j changing, and here instead of minus the plus will come, that is 1 divided by 8j 1 divided by e raised to j omega plus pi by 4 minus 1 by 4. Then we have to add of this. Then I'll putting as x of e raised to j omega is equal to 1 by 8j 1 divided by e power j omega minus pi by 4 minus 1 by 4. Here the sign based on this sign minus, for that reason minus 1 divided by e raised to j omega plus pi by 4 minus 1 by 4 you will be getting out. This is very important in the Fourier transform, and also in terms of DTFT you will be getting the same. Okay, almost similar, only thing a small changes are going to be occurring. Then about next problem is of find the DTFT of the sequence x of n is equal to alpha raised to n cos omega naught n plus pi u of n. Then solution is going to be x of e raised to j omega is equal to summation x of n e raised to minus j omega n. Substitute for x of n here. Then cos in terms of exponential terms, that is I can write as e raised to j omega naught n e raised to j pi plus e raised to minus j omega naught n e raised to minus j pi. Okay, divided by 2. Then e raised to minus j omega n. But it will be getting as e power omega naught n plus pi. Again it is different, bifurcated that value. Then you will be getting as 2 exponential. Don't confuse that only one e will be coming, how it is came as 2. Okay, that e power omega naught n plus pi, it is bifurcated, divided. Okay, then multiplying for each parameters, then I'll be getting as 1 divided by 2. This 2 is taken outside and e raised to j pi is a constant that is taken outside here. Summation n is varying from 0 to infinity alpha e raised to j omega naught into e raised to minus j omega power n plus 1 by 2 e power minus j pi outside taken. Then summation n varying from 0 to infinity. Then I can write alpha e raised to minus j omega naught e raised to minus j omega power n. Solve for this. You will be getting as, that is x of e raised to j omega is equals to 1 by 2 e power j pi. This is nothing but 1 divided by 1 minus alpha. Alpha is nothing but the whole function. That is written as 1 minus alpha e raised to minus j omega minus omega naught. Here it is added. Okay, powers are going to be added. Plus 1 by 2 e raised to minus j pi 1 divided by 1 minus alpha e raised to minus j omega plus omega naught. Okay, this is of the problem. Next, find the DTFT of the signal. X of n is equals to cos pi by 5 n plus j sin pi by 5 n, where mod of n is less than or equal to 10. Here the problem it is given. Given that here the function is given, written as it is, then this I can write in terms of, this is in terms of cos and sin, which is the parameter is of cos theta plus j sin theta is nothing but e raised to j theta, right? That's here it is written. So we'll be getting as x of n is equals to e raised to j pi by 5 n. Then substituting for x of n, use the equation for DTFT and then substitute for the x of n. Then substituted here, e is varying from e right power j pi by 5 n e raised to minus j omega n. What is the limit is going to be? Observe here, mod of n is less than or equal to 10, means within minus 10 plus 10, both the limit. Observe here, n is varying from minus 10 to plus 10 because it's a mod of 10. It will be less or equal to 10. For that reason, limit is going to change here as n varying from minus 10 to plus 10 and remaining as it is. Then put which parameter is given, that you have to take here, that is m is equals to n plus 10. Then change, after changing the limit, then I can substitute here as, where m is varying from 0 to 20. Here 10 n is of 10, 10 plus 10 is 20. For that reason, limit is going to change from 0 to 20 e raised to j pi by 5 e raised to minus j omega power n. What is the n is of? That is n is going to be m minus 10, m minus 10. Then this power minus 10 is taken outside of this part, that is e raised to j pi by 5 e raised to j omega power minus 10 summation m equals to 0 to 20 e raised to j pi by 5 e raised to minus j omega power m. Then this is in terms of power, is in terms of minus, that minus is taken inside, means multiplied for the power. So I'll be getting as e power minus j pi by 5 e raised to j omega power 10. I hope you got this. Okay, then what is m? M is going to be m plus 1 time the next equation. So I can write as 1 minus e power j pi by 5 minus omega power 21. What is the upper limit is going to be 20. 1 more extra, alpha power m plus 1. 20 plus 1 you will get, divided by 1 minus alpha. 1 minus alpha means alpha is of this part. E raised to j pi by 5 minus pi. Here it is added here. Okay, powers are going to be added here. Then simplify this. Okay, then you will be getting as x of e raised to j omega is equals to sine 21 by 2 pi by 5 minus omega divided by sine 1 by 2 pi by 5 minus omega. This is the you will be getting of. Then find the DTFT of the signal. X of n is equals to 2 minus 1 by 2 power n, mod of n is of less than equals to 4. For other values it will be 0. But first you have to substitute for x of n in the DTFT equation. Then multiply x of e raised to minus j omega n. Next we have to do multiply e raised to minus j omega n for this part and also for this part. Then summation varying from n varying from plus 4 2 into e raised to minus j omega n minus 1 summation n varying from minus 4 to 5 for the next parameter, that is 1 by 2 e raised to minus j omega power n. Then put m is equals to n plus 4, so that I can write as limit is going to varying from m varying from 0 to 8 and this part as it is, and n is going to be changing as m minus 4, that's here written, and here also the same, only n is going to change as m minus 4. Then here 2 into e raised to j4 omega, this part is taken outside. Then the remaining is going to be, after applying the limit, you will be getting as 1 minus e raised to minus j 9 omega divided by 1 minus e raised to minus j omega. If you solve for this, you will be getting as 1 minus 1 by 2 e raised to j4 omega 1 minus e raised to minus j 9 omega divided by 1 minus e raised to minus j omega. When you solve for this in abbreviated form, you will be getting as x of e raised to j omega is equals to 3 by 2, 2 minus 1 by 2, 3 by 2 e raised to j 4 omega 1 minus e raised to minus j 9 omega divided by 1 minus e raised to minus j omega. Then determine the next problem is of determine the signal having the following DTFT. X of e raised to j omega, it will be 0 when omega is varying from 0 to omega naught, and it will be 1 when it is varying from omega naught to pi. Then we have to use the in terms of time domain function equation, that is x of n is equals to 1 divided by 2 pi integration minus pi to plus pi x of e raised to j omega e raised to j omega n d omega. What is the limit is varying from? From minus pi to, because it's a mod, minus pi to minus omega naught, it will be 1 e raised to j omega n d omega, then 1 by 2 pi. Here for the positive values from omega naught to pi, 1 into e raised to j omega n. Do the integration, apply the limit. I hope you can do of this simple. Go on doing of this, you will be getting as this. Then I can write as 1 divided by n pi e raised to j n pi minus e raised to minus j n pi divided by 2j is nothing but sin n pi. Then here is of e raised to j omega naught n minus e raised to minus j omega naught n divided by 2j. Here it will be as minus sin omega naught n. Therefore x of n is going to be, after solving this, minus sin omega naught n divided by n pi. N pi is, it will be 0 for that reason. Okay. Okay, from this